of them. The thymus is going to be part of the lymphatic system. So for the development, or the maturation, I should say, of T cells, they go to the thymus, and therefore it's lymphoid tissue.
When do our bones change to not all produce red blood cells?
At puberty. Well, it's still going to go actually until you stop growing. So in females, roughly about 18 years of age. In males, about 21 to 25 in age. So after now the adult stops growing, then blood cell production is going to change. So how do we get all of it? Let's go back to thinking about a stem cell. What's your understanding of a stem cell? They can turn into different types of cells. Anything else?
They help create more cells.
They help to be giving rise to other cells.
They can be put in the organ and actually start doing what the other cells are doing.
Now, you're getting into my stem cell controversy, which is not needed, but anyway. Stem cells. What we're being told is the stem cell has not been differentiated yet.
They're blanks.
Yeah. They're a blank slate. Meaning, if they receive the proper chemical, did everybody hear what I just said? If they receive the proper chemical, i.e. a signal, they will differentiate into something. In our bone marrow, blood cell production, white blood cells, platelets, they come from one stem cell. Meaning that one great big huge cell, when doing its job, gives rise to my white blood cells, my red blood cells. I call it pluripotent, because that's what I was taught. They now refer to it as the hematopoietic stem cell. The common origin. You may see it as multipotent or pluri, meaning more than one, because that's what it does. It gives rise to more than one type of cell. What's going to happen? It is going to be able to give rise to colonies. That's how they refer to them. So we will have a colony for my lymphoid cells, and then my monocyte cells. Boom. What we get from this is something called my colony forming unit, a CFU. So my stem cell gives rise to a CFU. These give rise to one of my elements, one of my formed elements. Okay, is everybody with me? My blood plasma, which is my matrix of the blood, gets continual replacement from nutrients from the digestive tract, because that's where my nutrients are getting absorbed from. The rest of my blood, the part that's going to be making up the red blood cells, the white blood cells, and the platelets, I'm now dependent on this one stem cell. So, I get colony-forming units that will give rise to lymphocytes. I get a colony-forming unit that will give rise to my erythrocyte, which is my red blood cell, my platelets, basophil, eosinophil, neutrophil, and monocytes, the macrophages. So 1, 2, 3, 4, 5, 6, 7, all 7 of the formed elements. That one great big huge cell, do you happen to remember what the interior of a bone looked like? For example, a long bone.
Say a long tube filled with like material.
Do you remember what it was called in between
Marrow?
the compact bone? Spongy. Why was it called spongy bone? Had spongy appearance. Okay. So, here's what gets to happen. If this is my compact bone, and this structure right here would be making up the entire outer portion of the bone. So, let's say that I'm taking let me try to get this up here. Okay, so let's say that I've got my long bone, okay, and this is representing a small section of it, like I cut through it, okay? Now, the outer portion is all of this right here. This is running all the way around. Down through the middle of it is all of my spongy bone. Do you guys remember the trabeculae? The spongy, spicule looking type things? Here's what happens. One of these, one of those big stem cells is stuck in one of these areas of the trabeculae. And as it stays kind of stuck down in there, as it gets information, it produces everything. And the platelets is really cool. As that cell kind of stays stuck and blood flows over it, as it flows, pieces catch on these trabeculae. And all it's catching is a piece of the membrane, and that's my platelet. Is that not cool? So that one cell just sits there, waiting to give rise to a colony-forming unit. And it's like, okay, well, I got the signal. Form the unit. Oh, got another signal. Oh, form the unit.
Do these cells duplicate or repair, or is it
Yeah,
once they're
they
spent,
just-
they're done?
No, the stem cells, okay, because this is something that is fluid and constantly in motion, we're producing. Is that not cool? Yeah. So, blood cell production. We'll pick up at the next part Tuesday. Have a good weekend.
So what's the controversy? Why is there a controversy if this stuff replenishes itself and it's all blanks?
The controversy is over how they harvest. Oh, one of the ways to truly harvest stem cells, which is the aborted fetus. And there's a lot of controversy over that.
So people don't just go into like your body and take some from
They are
there.
learning to do that now, mainly because of all the controversy and the way that they have been restricted in getting stem cells. And so now they have learned other ways to harvest stem cells in their own body and use them. Not the production of the blood. Not the production of the blood.
Okay.
Yeah. But now, some of the, like for example, some of the cancer treatments are based on harvesting some of your own cells, kind of modifying them, and then using them back in your body.
What compression do you wear?
Huh?
What compression do you wear?
I don't wear the heavy one. It's only like around 10,
15 to 20?
10 to 12.
Oh, you're.
Yeah.
Okay.
Yeah.
How much do you pay for it?
You know what? I don't remember. Because these are like those Tommy Copper.
Ugh, I wear those.